Hello everybody. Today I am going to take you through a very brief overview of the ATV31 installation manual. So the very first thing that we are going to want to do is make sure that you received what you ordered. And that goes for any piece of equipment. So this particular family of drives has a few different options for heatsink, has a few different options for power rating. And when I say options, I mean they're just classifying the VFD according to those power ratings, and that's also going to impact the frame size and everything else. These drives can have a single phase input or a three-phase input. And yes, even a single phase input VFD can have or simulate a three-phase output. Uh, Once we rectify, if we can take a rectified DC and make three-phase, it doesn't matter what's coming in, so long as we can rectify and create a DC from that. Let's carry on to page 10, some of our environmental considerations. So, as many of you, I'm sure, are aware, or some of you anyways, your fancy smartphones that you have something called an IP rating. That stands for Ingress Protection Rating, and all equipment has this rating. What it is it's the degree of protection that that piece of equipment or disconnect or smartphone or motor starter, whatever it is, has against solid objects. And then that's the first number. And the second number is the degree of protection against liquids. So splashing liquids being a lower degree protection compared to falling or spraying liquids, and then being able to be directly submersed. There is a table in Appendix B in your code book that tells you what all of those numbers are. It can be found in the hazardous location section in Appendix B. So our equipment's going to have a similar IP rating. That IP rating is going to change if we happen to take the top cover or the sides off of the drive in order to improve airflow, to improve cooling, ventilation. Let's go down here to our electrical characteristics. So as I said, we can have single phase drive, three-phase drive. Some have a filter, some don't. The filter is used to mitigate some of the effects of the nonlinear loading. So harmonics, third harmonic in particular being most damaging. So some have filters, some don't. We can always add an external filter. The output voltage will be equal to the input voltage. These drives can simulate an output frequency of up to 500 hertz. So that means, to compare in North America, of course, we have a standard 60 hertz. So we can increase that output frequency beyond 60 hertz, and that essentially will allow the motor to go faster. If you're going to run a motor above its base speed, you need to be very careful to consult with the manufacturer and make sure that the motor that you have coupled with the type of load that it's moving, that it's pushing, uh, keep things safe. The manufacturer wants their equipment to work well for you. So switching frequency is another frequency. This is different than the simulated output frequency. Switching frequency is the rate of switching of the IGBTs, insulated gate bipolar junction transistors, in the inverter section of a VFD. So in order to simulate a waveform, we have IGBTs switching really fast, or they can switch really fast. And that basically improves the current waveform that will be drawn by the motor, which improves the performance and the efficiency of that motor. Carry on to page 18. Now we have talked about cooling, and these are motor controllers that give us speed control. They tie into, or can tie into, larger systems, so they're computers essentially. They have inputs, they have outputs, they have an interface, depending on the type of drive it is. So there's a lot of electronics. And what that means is it needs to be kept cool, and that environment needs to be kept clean. So based on the model number of VFD that you happen to have, they require a certain flow rate of air in order to keep that cool. Now, generally, this type of equipment is installed in, mills, that sort of thing, very dirty, dusty environments. We can't have dirt and dust going in, clogging up our electronics, um, clogging up our heat sinks. They're not going to cool as well. So they're installed in sealed cabinets, and we're forcing air through them. So that also means that we have air filters. Those air filters have to be changed. Otherwise, essentially, you're reducing the airflow, and the drives can overheat and they can experience damage. On to page 26. And we'll just scroll down here. So when wiring to something that's been soldered onto a circuit board or a very smaller connector, I know we quite often want to just tighten it up as much as we can, but realistically, you don't want to do that. The manufacturer doesn't want to do that. If you over tighten one of those small screws, eventually it's not going to be tight. It'll feel tight, but that conductor won't be tight under there, and that can cause loose connections, which can cause arcing and sparking, overheating, fires, failure of equipment. So there is a recommended torque for each size of wire based on the model number. And the answer to your question is yes, you can get torque screwdrivers. So not torque wrenches, but torque screwdrivers that are very suitable for this sort of thing. Carry on down to page 27. This is our power terminals. So just as far as identifying what the power terminals are, line 1, line 2, line 3, RS and T, I would imagine you guys have seen those before. We have a DC bus on the inside, which is where our rectified waveform goes to. So that's PO, PC minus. We have an output to a braking resistor. So if we are going to brake with our VFD and brake fast, it actually will feed back energy into the drive and increase the voltage on that DC bus. That can be a problem because if it gets too high, we're going to cook our capacitors, we're going to fry some of the electronic components within the VFD. And we'll carry on to page 29. And this is our control terminals. So the wiring for our control terminals. I just want to talk a little bit about the functionality of each one and highlight the electrical ratings for each one of these things. So it's very important that if you're wiring up controls or power, that we never ever exceed the voltage or current ratings for those terminals. And sometimes they're very, very small when it comes to control wiring. So you need to be very aware of what they are if you are doing that wiring. So R1, A through C, these are basically they are outputs. So they're a relay type output. So there's a normally open, a normally closed, and a common for each one. So if the drive were to go into a fault, we can switch a signal, which would go to a PLC or something monitoring the state of the drive. And then that larger system would also know that there was a problem. We have analog inputs. So we have analog input or AI1 and 2. These are both voltage inputs. They take a voltage signal from 0 to 10 volts, 0 to 10 volts again. Analog input 3 is a current input. So it will take a 4 to 20 milliamp signal or a 0 to 20 milliamp signal, but we have the flexibility to adjust that. And again, that is used as the reference, the speed reference for the drive, so it knows how fast to make that output frequency to control our motor. This is the wiring for the drive. So power coming into line 1 through 3, power going out, T1 to T3. The drive does have its own internal 24 volt power supply and common, and 10 volt power supply and common to drive the logic inputs and to power the circuits for the analog inputs, analog input 1 through 3. That's about all I was going to go over with you guys. So there is a little bit more information in this manual. So take a peek, and we'll see you in the next video. Thank you very much. Bye for now.